That last session went a little long, but we've got a break after this one, so I'm not too worried about it. One thing I found interesting, and especially yesterday when I was talking with several people, there's not a whole lot of monitoring going on. A lot of people just kind of set the database up, and it seems to run fine, so they don't really worry about it. So this is this is your common view of the database. You put the data in, and it sticks there until you grab it back out and work with it. But what's really going on under the hood? If you're not monitoring it, if you're not looking at what's going on with it, then it's really just a black box. So, let's see. When we talk about monitoring, there's actually a few things that we tend to look for. The performance of the system itself, like the underlying layers, the operating system and the database. We look at the application throughput, and we also tend to worry about, is it dead or is it about to die? So the problem that arises is different people care about different things. As you're looking at this list, depending on your role in your company, you may look at that and say, okay, I care about that, but I'm a developer. If it's going to die, that's someone else's problem. I don't really care. So before we turn on monitoring and before we start sending out emails all over the place, we have to consider who we send these notifications to. So an application developer may care about system performance because that's their application. They've spec'd out to the operations people this system, and if it doesn't perform, then they want to know about it. They also want to know about application throughput because that's their code. If you're an ops guy, you obviously care about the system and how the disks are performing, and if you're doing it, and you also want to know, is it going to die? Is the disk ready to fail or something along those lines? The pointy-haired boss, I couldn't really find these are off of like a clip art site, but they didn't have anything like that. But they care about, is the system dead, or they care about the application throughput. Mostly, is it making me money? Someone once said, and I think the guy who told me this quote is in the room here, they don't really care about it. They don't care if the system's on fire. Is it making me money? So before you start sending long lists of reports about system performance and what's going on to your CEO's BlackBerry, consider who you're sending these notifications to. So anyway, what we wanted to talk about is what can we look at in Postgres on the internals? Well, we can look at the logs, and actually we can split the log monitoring into two different categories. We're looking at the logs for errors, faulty queries, or notifications that something bad is happening in the database. And we can trace the logs for queries that have just run, like you just saw if you're in here for the Enterprise DB thing, and measure the performance. We can also run external commands, look at the control files, look at things in Postgres itself, and we can then grab the database statistics and run analysis on that. So let's start at the monitoring for errors in the logs. Queries that fail can fail in many different ways. It can result in an error like just a logic error, division by 0. You can see errors in the logs like password authentication failures, stuff that prevents people from getting in and doing what they need. And you can get stuff that you really don't want to see, like no space left on device. That's not what you want to go back and see in the logs from yesterday. So we have a solution for that. There's a product called Tail and Mail. We can find it here at bicardo.org, wiki, Tail and Mail. By the way, these slides will be online, so don't write too fast. It's written in Perl. It's kind of lightweight as far as its requirements. Either NET, SNTP, SSL type of, I think there's a couple different program modules that provide that. Or it can just call a sendmail binary if you don't really want to worry about putting too much of that Perly stuff on your system. It's a slight misnomer. It's not an actual active process that's tailing a log. It's called from a, we'll get into that, but it's called from a cron job, and it keeps track of where it last scanned the log, and picks up from there, and then analyzes the next section that it reads. In the, I thought this was kind of cute, in the binary itself, at the very end is a sample configuration. So to get that, you just do tail and mail, and it spits it out, and you can save it. And it looks kind of like this, but if we wanted to create one from scratch, we give it an email address, where it sends it off to, so, a from line, tell it where to find the logs, and it's actually pretty smart about that. And give it, I think these actually are regular expressions that it uses. So actually, in theory, this isn't really limited to Postgres, even if it's kind of designed to look at those logs. But like our examples, we're usually looking for errors, fatal conditions, or absolute database panics where it's shutting down. So that's in a tail-and-mail.config file. You'll also want a tail-and-mail RC, a resource file, that contains your logline prefix, and we'll get into a little bit more about that. If you were here for the talks yesterday, you've probably heard about logline prefix and what that means as far as analysis, but we'll talk about that a little bit later. If you're using syslog, also tell it that it's looking at a different thing. More or less, you can copy that from your postgres.com file. So, once you got those two files in place, run a test on it, Perl, tail and mail, and pass it your configuration file as a parameter. Now what that'll do, in theory, it won't give you any output there because it sends an email. It's designed, again, like it's designed to run from a cron task. If it gives output there, you'll get 2 emails. So it's designed to be quiet unless there's a problem. Because you want to find out the panics, the important errors really fast, tell it to run every minute. And this is a line you can do to run that. And so what you get is something like this. This is, I think a couple days ago, one of my clients, they aren't in production yet, but they rebooted one of their databases. It's doing a hot standby. And all of a sudden we started getting replication terminated by primary server. I think this must be on the standby. And we called them up like a minute later and like, what are you guys doing? I mean, we knew that they were going to reboot it, but they were pretty impressed that we knew really quickly that something was going on. So the problem is, if you're scanning the logs once a minute for everything that's an error, a panic, a fatal, what if an error is part of your application? If someone creates a new user account or tries to create a new user account, it's theoretically perfectly valid to try to insert that row and capture the error that says, okay, there's already something there. So first of all, copy this, because we're going to want to keep this file, and I'll tell you why in a second. But add a line down here that says exclude, duplicate key, and that's continuation on the same line, duplicate key violates unique constraint. That's fine. I might want to know about that later, but don't tell me 30 seconds after this happens. So, but something like that you might want to learn about later. If it's a logic error in the application, someone accidentally has a condition where their query divides by 0, you might still want to know about it. So that original file that has panic, fatal, error, and everything that falls into those regular expressions, send me a report once a day that has all that. And if you keep your same file around, call it .error, it'll still do that. And you can it keeps track of the location at last scanned, and in that configuration file, it updates itself. So you can have multiple files looking at the same logs, and and it won't confuse itself, essentially. I should have included an example report, but oh well. So, by default, anything that only shows you the stuff that's erroneous, that had a problem. The logs can have all kinds of other useful information, like query performance. And by default, successful SQL isn't logged. So in your PostgreSQL.conf set, log statement equals all. And there's a log statement duration that you want to set to, or log duration. But on a production system, that can be pretty intense on your logs. So what a lot of people do is set that to DDL so that it tracks any changes to the structure, just because you typically want to have that logged, and set your log minimum duration statement to something like 200 milliseconds. That way, that all your normal queries that execute really fast aren't logged. They don't affect the performance at all. But anything that takes a long time, anything that's long running, you'll see. And I mentioned we'd talk about this a little bit more. Your log line prefix, you'll probably want to have something like this, and I'll tell you why in a second. There's a couple different products that'll take care of that. PGFuine, if you were in Greg's talk yesterday, he mentioned that, is pretty strict on the prefix, the format of the logs, and PGSI is to some extent. It's a little bit more flexible, but for PGFuine, it's pretty strict. That's found here. It's I think it's got another website, dedicated website, but it's probably easier to find it under the projects.postgresql.org site. It's written in PHP, which for a shell script, that's kind of a weird thing, not really seen too much, but it generates a web page, so maybe that's okay. It's a little quirky, like I said, regarding like the log line prefix. It needs that in a specific format. It doesn't really care about stuff that's after that format too much, so that's why we can be a little bit more flexible. If you schedule it, run it in wrap it in a script. Something that'll find your logs, maybe do a little bit of, you can grep stuff out of it if you wanted to, if PGFuine is confused about something or you don't really care about it analyzing a database. Pipe it into PGFuine, give it your log type, and direct it out to a file. I didn't include like the bulk of the script, but you can imagine what a script like that might look like. And then schedule that in cron. And it actually produces something pretty good looking. Here's a good example. For something that stands alone, it's actually a pretty well stylized, but it tells you the total duration of specific statements. It does some analysis on the different queries to try to normalize them and try to figure out what's similar. Tells you how often these were executed, and average durations and things like that. So there's another product that kind of does the same thing, part of the bucardo.org collection. It's written in Perl. It's a little bit more tolerant of the log line prefix. If you give it what you gave PGFuine, it's usually fine. The invocation is pretty similar. Just put it in the wrapper script that finds the logs. I think it can do it itself. Actually, yeah, this one, it just does it itself and do the same thing where it's piping it to an HTML file. And it's just not as pretty, but it does give some slightly different information, standard deviations. You can get it to give, I don't know if I actually got around to committing that, but I had at one point a part of a script where it gives a histogram of the queries. So if your average duration is, it's fine to know the average duration, but if you have a spike way at the tail end where 20% of them are taking 30 seconds to run, even if the rest of them are pretty quick, then it might be a good thing to know that. But you say, Josh, that's old stuff. I want to see what's happening right now. And besides, who relies on email for their notifications anyway? So we have a product called Check Postgres. This is kind of the meat of what I wanted to get into for the talk anyway. It is designed to plug into Nagios or some type of similar monitoring system. It's actually a collection of a whole bunch of different monitoring actions. It's found on the bucardo.org website. It's written in Perl. Are you seeing a pattern as far as the stuff on that bucardo.org does? We like Perl a lot at Endpoint. The requirements as far as it's running required vary a little bit depending on which action you're doing. But in general, the invocation is something like check Postgres -- action equals something. If you want to include a specific database or table or something like that, or exclude a specific object, you can do that. And if you're doing Nagios monitoring, you can give it specific warnings and warning thresholds and critical thresholds. So here's some of the more important actions in Check Postgres. The backends will count the number of connections, and we'll compare that to the number of maximum connections in your configuration file. The thresholds are actually really flexible. You can either give it an absolute number, which says, okay, I want to know if the number of connections passes 200. You can give it a percentage that says, okay, I want to know if the number of connections passes 70% of my max connections in my config. Or you can say how many are remaining. It's like I think you give it a negative number and say, okay, I don't really care how many connections are there. Just let me know when 10 are left. And you can actually tell it to ignore any idle connections in its count. So you can ask it how many running queries you have. Another one, which is really handy to have, is a bloat check. It's pretty sophisticated. It uses some type of estimates and has this really complicated query that looks at to figure out, okay, how much data do you have in the database, and theoretically, based on the size of the rows and how many rows you have, how much space should that be taking? And it'll calculate and tell you, okay, your table's 4 gigs in size. It really should be 1.5. So again, you can include specific tables if you're worried about like a sales table or a queue table that has a lot of churn. I got this fortune cookie a couple years ago, and I thought that was hilarious. But this is the action is bloat is one place where you really want to make sure that your database is analyzed well, because it uses those statistics to determine that. And if you want to find the query, just grep for this line in checkpostgres.pl. It's enormous. It'll make your eyes bug out when you look at it. And if you do understand it, like just looking at it, send me a resume. Okay, what else we got? We have query time, which probably should be plural. It actually looks at all the running queries on the system and tells you, do any of the queries pass over a certain threshold? And it's actually you can get pretty sophisticated as far as the thresholds. If your boss way at the top is one of those guys that really insists on writing his own reports, and he's got one that does a sequential scan over every table in the database, and he says, I need this to run. It's like, okay, fine. We have capacity on the system. Let that query run as long as it needs, but let me know if he runs 2 of them. So you can ask it to do that. Idle transactions are really bad. Anyone you ask is going to tell you that. So knowing that stuff is just hanging out in the database is really good to know. It's kind of mostly the same code as the query time, so it can use the same thresholds. If you've got a known problem that some part of the application, maybe it's a maintenance script or something, leaves a transaction idle for a while, someone's going to fix it soon. But for now, just let me know if other things do that. You can say, okay, just let me know if 2 things leave a connection open for an hour. Transaction wraparound. Vacuum should be doing this, or auto vacuum should be doing this. But if it's not, for some reason, if there's a large table that's having problems getting through, that'll let you know. Especially in like a high volume database where you've got thousands of or hundreds of thousands of transactions a day. It'll let you know if you're approaching wraparound, because wraparound will take your database down to do an emergency vacuum, and if you're not expecting that, that's not good. So a couple additional actions. Something that's useful if you've got a warm standby or doing a wall replication is the checkpoint action. It doesn't really sound like it right off, but it doesn't need a connection to the database. It actually looks at the PG control file and in the output from PG control data to determine that. So if you've got a warm standby where you can't, like an 8.4 system or earlier, where you can't connect, but you still want to know, okay, is the wall keeping up? It'll tell you the last time that a checkpoint that it read a checkpoint in from the wall data. On the other side, the archive ready will tell you how many unarchived wall files you have just hanging around. If your archive command starts failing and you're not doing tail-mail or something like that, this will tell you if those start accumulating. If you're doing hot standby, there's a hot standby delay. It actually connects to both sides and looks at the last wall location and compares that. And if it's not keeping up, then it'll start letting you know. There's a few sanity checks in check Postgres, database size. There's no default thresholds for that, of course, because there's databases of all different sizes. Very similar to that, there's a relation size, and if you want to know if it's like a Q table is getting too big, you can check that. If your wall files are starting to line up and you're worried about that running out of disk space, you can monitor that. Kind of a sanity check is make sure that when the last time auto vacuum or auto analyze ran. That might be a little tricky because sometimes if it's a new database, you just load the data in, it doesn't think that auto analyze or auto vacuum needs to be run. So for something that's been running for a while, of course it'll have that data in there, but it might be a little tricky to get up and running off the bat. If you are doing prepared transactions, we've got, I think, one client that's doing it now. It's not that common, but if you do, this will keep an eye on the age of them just to make sure that whatever prepared transaction process is cleaning them up appropriately. Just because, like idle transactions, those can cause problems in the long term. Another new version _PG will actually go and look. I think it looks at the Postgres website directly and tells you if there's a new minor revision released, which contains security fixes or bug fixes or things like that. It ignores the major version. And if there's anything else that this doesn't cover, you can give it a custom query. And if you find this really useful, please let us know. Submit a patch. I mean, we're definitely open to improvements to the product. I've thought about creating a patch for like a --sane version that gives you a warning as soon as the version you're on goes into end of life, and gives you a critical as soon as it's declared obsolete. But I don't know if that's a good idea yet. People, long running red on the Nagios tends to get overlooked over time. So, one of the interesting things about check Postgres is it doesn't necessarily have to plug into Nagios only. It does metrics too. There's a number of different output types that it can do. If you've got MRTG, it'll do that. Cacti, a lot of the Nagios outputs are in a Cacti compatible format already. And if you just want like a metric on the output of the command, you can just have it do a simple number. And plug that into Graphite or Cacti or whatever your graphing solution is. And in a minute, I'll talk about some of the other statistics that we can get from Postgres. So, one we've already talked about, backends. Really good to know over time whether your connection count's growing, or is your database needing to handle more connections than it used to. So plug that into Graphite or Cacti or whatever your graphing solution is, and start plotting that. Here's a longer view of the same data. I think at one point they started using a connection pooler, so it made it nice and flat. I don't think we talked about the locks check, the locks action. This is kind of example output. It is Nagios compatible. It also has the Cacti format at the end that they can use to plug into that, and results in something looking like that. Let's see what else. I think we talked about database size before, or relation size. Something like that's good to know over time. DB stats is one of the ones that's not really good for monitoring, but if you're plugging into some type of a metrics collection, really good to have. It's a Cacti-friendly view of the PG stats, or stat database view. Also, the hit ratio, which is the for a specific database, the ratio of database reads from disk to hits in the cache. So, is your cache sized correctly? Well, it might be now. Is it sized correctly in 6 months? This will keep track of it. But you say, okay, I don't have Cacti. I want to get that installed, of course, but the budget's not there. My boss says, okay, don't do that now. Postgres has, you might be familiar with these already, different statistics views. Like PGStat database, these are of course truncated just for sanity and fitting them on the slide. There's PGStat user tables, PGStat, BG writer, the checkpoint performance, and when you think about what you're running here, these are relations. I mean, this is like any other table or any other data in the database. We can actually work with it. So start collecting it. Put something like this in a cron job that takes a snapshot of that every 5 minutes, an hour, or whatever you think is necessary, and you'll have that the baseline to compare to what happens down the road if things start heating up. So yeah, there's your poor man's metrics collection. So how are we doing on time? I think we're getting a little bit close to the end of our time. So things to consider. There's other things to monitor. The OS, the hardware, load balancing. If you're doing replication, you want to keep an eye on that. I'll go through these pretty quickly. Nagios and your monitoring system, whatever, it's going to have a lot of these by default: disk space checks, CPU utilization, load averages, process counts. It does that for a reason. It's always a good idea to collect that and keep an eye on that stuff. Also, see, there's I love the SysStat package. The SAR has it collects snapshots of CPU, network utilization, memory utilization, all kinds of stuff, and keeps it for a certain period of time. You can go back and review that later. It also provides nice utilities like IOStat and stuff that's good to have on a database system. For hardware, see what your vendor provides. It just really depends. If you've got a connection pooler or load balancer, usually they provide their own metrics. If you're using PG Balancer, check Postgres has checks for that. You thought I was done talking about that, didn't you? No. So I was going to do a little bit more about Graphite. I'm actually working on some stuff for getting extra data from check Postgres and even like tail-mail and stuff like that into Graphite, because correlation, being able to combine graphs and see how things relate is really useful sometimes. So we looked at log monitoring for different types of purposes for errors in query performance. We looked at check Postgres and the external commands that can read from the database, and we looked at the statistics from the database itself. That's pretty much it. Are there any questions? Yeah, looks like we're pretty much right on time for our break. I don't have them up here yet, but for those, as I said, don't write too much. You might want to take down this note. And actually, they're going to be on the Postgres Open. Selena sent out an email asking for the slides so that she can post them there. But they're going to also be up here pretty soon. They're not there right now, but I'll have them up there, by the end of the conference. Okay, if there's no other questions, I believe that is all.